Hello, welcome back to my channel. We continue to build our project. In the previous video, we implemented the GPA auditing feature. In this video, we will implement JWT Authentication. Before we continue, I want you to know that this channel is all about growing as software engineers together. If you want to join, subscribe now. Okay, for the project structure, I will create a folder for all authentication related files. Then I will implement a custom UserDetails class to use for JWT authentication. You can also use your user class, it's totally fine, but I prefer this way. I declare the variables I want to use in my custom UserDetails class. Then I initialize these variables in a constructor. I will use a user object as a parameter in the constructor. As you can see, there's an error in my code because I haven't implemented the necessary functions yet. I implement them now. I forgot to add getter and setter annotations. Let me add them quickly. Okay, let's implement our authentication service. I use service annotation right before the class because it's a service component. Before implementing the necessary function, I need to inject the user repository because I will use it later in the function. I added the necessary function using IDE's functionality. In this function, we will check if a user exists in our database. The original function uses a username as a parameter, but I will use an email address for this purpose because we don't keep username information for users. It says that we don't have a function to find by email. It's okay, Spring GPA can automatically generate it for us. If the user is found, we return it as custom user details. Otherwise, we simply return null. This is done. It's time to implement the necessary DTOs. We start by implementing the user creation DTO. I add getter and setter annotations as well as the necessary class variables. We continue with the user response DTO. I implement this because I'm planning to use this DTO when returning a user object. Therefore, I won't return irrelevant data such as password or created by data. The login DTO is simple. It is for getting a user's email and password for login. After that, we need to implement the mappers for these DTOs. I start with the user response DTO. I get a user object as a parameter and I instantiate a user response DTO object, then I choose the data I want to return. In the second function, I convert a user DTO to a user type to save it in the database. I get a user create DTO as a parameter. Then I declare a new user object. I set all the necessary fields. But there's a catch for the password field though. The password value that comes from the front end must be hashed in terms of security. We never store the passwords in plain text format. Another element that would be useful is exceptions. We will be using them a lot. Our first exception will be UserNotFound exception. It's pretty straightforward to implement an exception. Yes, it's time to implement the user service. Like the previous ones, we begin with the interface of the service. We add all the necessary functions here. Of course, we will be adding more functions as we proceed with the project. Let's implement this interface. Since it's a service element, I add the service annotation here. Then I import all the required functions that need to be implemented. After that, I inject the user and school repositories here. In the createUser method, we first map the incoming user createDTO into a user entity using our mapper. Then we fetch the school from the database using the provided school ID and attach it to the user. After that, we save the user with the user repository, and finally, we map the saved user back into a user response DTO to return as the response. In the fetch user by email method, we try to find the user by their email address using the user repository. If the user is found, we wrap it inside an optional and return it. But if something goes wrong, for example, the user doesn't exist, we throw a custom UserNotFound exception with a clear message. In the fetchUserById method, we look up a user by their ID from the repository. If the user exists, we map it to a user response DTO and return it wrapped in an optional. But if the user isn't found, we throw a UserNotFound exception with a clear message. In the previous video, I told you that we would update the function for GPA auditing. Now it's time to update it. This is the final version of our method for now. It fetches the current authentication from the security context. If no one is authenticated, we return anonymous user. If the principal is a JWT, we extract the subject and return it. Otherwise, we return system. Now let's implement our UserController, which will handle the requests for the user module. It has the REST controller annotation, which means it handles HTTP requests and returns JSON. With request mapping, every endpoint inside starts with /API/user. We inject UserService through the constructor, so the controller stays focused on handling requests while the service layer takes care of the logic. The first endpoint is a post request add create. It takes a user create DTO, passes it to the service, and returns a user response DTO with a created status. The second endpoint is a get request add get user. It accepts an ID as a query parameter, fetches the user from the service, and returns it with OK status. Now we're moving on to the Authentication Controller, which is all about logging users in and giving them a token to access protected parts of our API. We start by annotating the class with REST controller and request mapping. This means all endpoints inside this controller will be available under the /API/authentication path. Next, we inject two important dependencies through the constructor. UserService, which lets us interact with user data. Authentication Manager, which Spring Security uses to check the user's credentials. We also load two configuration values from our application.yml. Issuer, which identifies who issued the token. JWT secret key, which is the secret we'll use later when creating JWTs. The error you see in the code will disappear when we implement the security configuration class. Now let's look at the main method, the login endpoint. We take in the login DTO from the request body. Then we call AuthenticationManager.authenticate with a username password authentication token. This step verifies whether the email and password provided are correct. If authentication succeeds, we fetch the user by their email using the fetchUserByEmail function. After that, we call a helper method createJWTToken to generate a token. I won't go into the details of how this method works right now. We'll cover JWT generation step by step later. For now, just know that this method takes the user's information and returns a signed JWT string. Then we prepare the response. We declare a hash map that contains two things: the JWT token itself and the user details converted to a DTO using UserMapper. Finally, we return this map as the response body with the status code 200 OK. Let's break down what the createJWTToken function does. We store the current timestamp in a variable called now. This helps us define when the token is issued and when it should expire. We create a JWT claim set that contains the information we want to include in the token. Issuer is our application, expiration time is 24 hours from now, subject is the ID of the logged in user. These claims are basically the data stored inside the JWT. Then we use NimbusJwtEncoder with our secret key to sign the token. Finally, we return the encoded JWT as a string. Now let's implement our security configuration class. This class is where we configure how authentication and authorization work in our application. Let's go through it step by step. First, notice the annotations. Configuration tells Spring that this is a configuration class. Enables web security activates Spring Security's web security features. We also inject the JWT secret key here for decoding purposes. Now let's look at the security filter chain bean. Here we are telling Spring how to handle HTTP security. CSRF is disabled since we're building a stateless API. Then we configure authorization rules. User creation and login endpoints are public endpoints, so anyone can call them. Any other request requires authentication. We enable JWT authentication here. Finally, we set the session policy to stateless, meaning Spring won't store session data on the server. Every request must carry its own token. This ensures our API is fully RESTful and secured by JWT. Now let's examine the second bean, which is the JWT decoder. Here we take the secret key from the application properties, wrap it in a secret key spec, and configure NimbusJwT decoder to use HS256 as the signing algorithm. This is what validates the JWTs that come with requests. Finally, the Authentication Manager bean. We define an authentication provider that uses our custom Authentication User Service to load user details from the database. For password security, we plug in a bcrypt password encoder. The Authentication Manager then ties everything together, handling the login process by verifying user credentials. Okay, now let's run the application and see if it's working as expected. I'm using Postman to send the requests. I have already written a dummy user object for user creation. As you can see, the user has been created successfully. Let me copy this user's ID to test the getUser endpoint. I use the ID as a request parameter. Yes, we successfully fetched the user data by user ID. It is time to test the login endpoint. The endpoint is expected to return a JWT token and user data together. Yes, this also works as expected. That's it for this video. If you have any question, write them in the comments. I will continue to build the project, so make sure that you are subscribed to my channel. See you in the next video.